So let's try to do 9.6 number 35 that's actually from 9.6 and not 10.1. I would like to cube root the complex number 1 plus I. Okay?
Okay.
So how do you take roots of complex numbers? What did we need? You don't. Think I need to convert to polar.
Oh.
Right? Yeah, to polar. Yeah, so graph the point.
Okay. This makes sense.
So that's over 1, up I. Right, so if I'm thinking about this as a triangle, right?
Yeah.
That's a triangle that's 1, 1, 90 degrees.
Okay.
Oh, which you'll note is a 45, 45, 90 triangle.
Yeah, yeah.
Okay, so if that's pi over, good.
Cool.
Okay, so I have an angle of pi over 4 for this guy. What's the radius?
Square root of 2.
Square root of 2. So I think 1 plus I is square root of 2 e to the I pi over 4.
Nice.
You guys with me on that? And then they asked me to find all 3 cube roots of this thing.
Okay.
Why are there 3?
Because it can cross the X.
Okay. What do you think about if I want to cube root this thing, how should I do that?
Well,
How do you cube root complex numbers?
1 over 3. Power 1 over 3.
Okay, you do this whole thing to the 1/3 power, right?
Yeah.
Okay, so I think the cube root of 1 plus I is square root of 2 e to the I pi over 4 all to the 1/3 power, right?
Yeah.
All on board with that?
Yeah.
Okay,
Crazy.
which should be the square root of 2 to the 1/3 power, which is like 2 to the 1/6 power. All with that.
Yep.
And then there's a e to the I pi over 12,
Yeah.
which is 15 degrees.
45 divided by 3.
Crazy, right?
Yeah.
Okay, cool, check. That's one of them. Where are the other 2?
Dun, dun, dun. The ones that are reference angles. Degrees.
Yeah, kinda. Let me think. So I tripled something to get to 45 degrees, right?
Yeah, you triple 50.
You guys see that? Like from that thing to get to the ant, to get to 45 degrees. I thought to myself, okay. So I took some angle, I don't know. Oh, what the heck? Let me call it theta. Right?
Okay.
I took some angle theta and I multiplied by 3 and I got pi over 4.
Yeah.
You guys all see that?
Uh-huh.
Okay. So I'm kind of dealing with this equation. Like 3 theta is pi over 4.
Yeah.
And you all are like, yeah, dude, that's this theta's pi over 12, right?
Mm-hmm.
Okay. But wait. That's one that's, what did you say? That was a good idea.
Plus pi.
Yeah, there's like maybe a plus pi or something.
What about negative?
You see that? Like, should be maybe plus
Plus pi times
2
n.
pi. 2 pi times n. I don't, like, there's something weird that's up with coterminal angles, right? So you multiplied something by 3 and you got to pi over 4, right? What's to say you didn't go all the way around to get to pi over 4?
Yeah, so what you have to do.
You see that? So it's not just pi over 4 that you have to worry about. It's like, well, what if you had pi over 4 plus 2 pi, for instance?
Okay.
So then your angle would be pi over 12, right?
Plus 2
plus
pi.
2 pi over 3,
plus 2 pi over 3.
which is 8.
Which is like a legit angle, right? Like, that's not something coterminal, that's something between 0 and 360.
Yeah,
You see that?
that's cool.
Okay, so that's another one, right? So I had one that was the regular, like, just divide by 3. And then I have another one that's, or 2 to the 1 over 6 e to the I, and then pi over 12 plus 2 pi over 3. Right, so that's, what if you went around once after you tripled? So what's the other option?
4 pi over 3.
Yeah, what if you went around twice, right? Is 15 degrees, right, your pi over 12, plus 4 pi over 3. And what if 4 pi over 4 plus 4 pi over 3? Or 4 pi?
Pi over
Sorry, it's 4 pi up here when I'm talking about pi over 4. And it's 4 pi over 3 after I divide it. So is that one still in the circle?
Yep.
Like, is that one still within 1 rev? Yeah, crap. So I really have 3 answers. So my answers are, it's 2 to the 1/6 e to the I pi over 12, or it's 2 to the 1/6 e I to the pi over 12 plus 2 pi over 3, or it's 2 to the 1/6 e to the I pi over 12 plus 4 pi over 3. And how do I know 6 pi is not going to be one of them?
Because 6 pi over 3 is 2 pi. That's it.
Yeah, 6 pi over 3 is 2 pi, so you get back to your just original pi over 12. You don't need to write that one down. It's coterminal with one of the ones you already listed.
That's awesome.
You guys see that's why I'm not doing minus 2 pi over 3?
Yeah.
Minus 2 pi over 3 would be this one again.
Yeah.
You guys cool with that?
Yeah.
That's a little funky, right?
Yeah.
So the rule is when you're cube rooting a number in the complex plane, you should look for 3 answers. If you were fifth rooting a number, how many answers would you look for? 5. And one of them would be hard, and the other 4 would, or sorry, one of them would be easy, and the other 4 would be kind of harder. Right, in the same way that one of these was easy and the other 2 were a little bit, Cool. Question?